Hello, everybody. My name is Nick, and welcome back once again to Flyout. You may be wondering why we have this particularly shiny aircraft here in front of us today. And the answer is we're doing another Flyout tutorial. In this tutorial, we're going to cover some more advanced concepts, such as how to make a plane fly when it's not inherently stable, how to use fly-by-wire systems, and how to build more advanced planes like this one, as opposed to more conventional monoplane, think like this type of aircraft. So without further ado, let's get straight into it. So in the last flyout tutorial video, we discussed how to build your first plane, just something that flies. It doesn't have to be pretty like this, or even good, also like this, but it has to fly. The simplest ways to do that, as we reviewed in the last video, are build a craft that has a center of pressure, or center of lift as we call it in this application, that is behind the center of gravity, but not too far behind, because if you put it all the way back here, weird stuff happens. And then you need your control surfaces. So on this plane, if it'll let me select them, we have our ailerons here, and we also have our flaps, and we have our rudder. So those give us different profiles of control. So the ailerons let the plane roll back and forth. The flaps back here allow us to pitch up and down, and then the rudder lets you yaw the plane left and right like that. So this is a basic plane. You can build any different configuration of this, put whatever you want on it. This is a tried and true formula. Now in this video, we're gonna go and look at a less basic approach. So for that, I'm gonna load one of our aircraft here. So, oh, this is the wrong one. Ignore that. That is a conventional aircraft. Maybe it was oh yeah, this one. Okay. So here it is. This is a flying wing, and note it's not finished because there's no glass in the cockpit, so this guy is just going in with his mask and nothing else. But you'll notice immediately something about this craft that's different from the one we were just looking at. If we look at the center of gravity, which is basically the center of mass of the aircraft, versus the center of pressure, you'll notice that the center of pressure is in front of the center of gravity. This causes problems for a few reasons in conventional aircraft. For one, this leads to an aircraft that is what we call unstable, which basically means if I tell this aircraft to pitch down, it's going to continue to pitch down harder and harder without any more input from me. Whereas a conventional aircraft, you tell it to pitch down, pitches down, and then tries to return to normal level flight. Now, this is a problem because if you're the pilot, this guy holding the joystick right here, you are not going to be able to control this thing. So the good engineers at some company in the 50s, I think, invented the fly-by-wire system, which we have right here. So I'm going to explain what each of these things does in order, and then we're going to do some real-world testing with this particularly finicky craft, and you guys will learn how to build your very own unstable aircraft. Also, just a quick note that flying wings like this usually fall under the realm of unstable or not conventionally stable aircraft. And they also, there are some advantages to that sort of a setup where you have this conventionally unstable idea. One of which is you can actually get more agility out of a plane by doing this, because even though we only put a tiny bit of control input in, tell the plane to pitch down, the plane will automatically, without any further control input, pitch down harder and harder until we intervene in some way. So this is actually pretty common in modern fighter jets. But anyway, here. One additional note before we start the actual process: a fly-by-wire system can also be useful on a stable aircraft. It can actually just help you to control the aircraft more accurately. So while these are needed for unstable or conventionally unstable aircraft, they're also helpful on other types, normal ones. You don't only need to use them for these sorts of crafts. Alright, so the first thing we'll discuss is how to actually access the fly-by-wire tab. So what you're going to need to do is you click on your little guy here, whose name I always seem to forget, and you'll see it's selected the fuselage for us. Just go ahead and hit this back arrow right here, and you'll be taken to the parts manager, I guess you could call it, and then click on cockpit. And that gives you the fly-by-wire screen. So here we're going to walk through all these different things, what they do, and how you should use them. So first of all, you have throttle. You can either do lever or pedal. Those are pretty self-explanatory. The real meat of it here is the fly-by-wire stuff. So the first thing we have here are 3 different gain values. So gain basically multiplies your input. So higher gain, more input. Lower gain, less input. So generally, you don't need to fiddle with these too much. But you'll see in this particular craft, I've increased the pitch gain because we want greater pitch input than normal, because this thing tends to veer downward pretty hard. So we need a lot of input to counteract that. So you have one for pitch, one for roll, and one for yaw. You can change them independently of each other. Then we have the damp rate. So it's either damp pitch, damp roll, or damp yaw. What that does, if you see the tooltip here, is it tries to keep the aircraft steady on the pitch axis. So this is basically how much control authority are you giving the fly-by-wire system to keep you steady. So if I put this at 0, that's no fly-by-wire. If I put it at 1, that's the entire control, or almost all the control authority belongs to the fly-by-wire system, which obviously you don't want because you need to control your craft. Now you'll see it's pretty darn high here because this thing is very unstable. It's not a well-built plane at all for pitch. For roll, I have it at 0.5, and yaw, I have it at 0.5 as well. Could probably reduce those since it's not particularly unstable in either of those regards, but still helps. Then we have the pressure damp, pitch, roll, and yaw. So again, we have one for each pitch, roll, and yaw, but pressure damp, again, looking at the tooltip here. So at high speeds, a little bit of control input can make a lot of difference. So what this does is it reduces the amount that your input as the controller matters while you're going at high speeds. You might think, why would I want that? I'm controlling the plane. The reason is, if you think about it like you're in a car, right? And you're going 90 miles an hour, and all of a sudden you turn the wheel all the way to the left. You're going to spin the car. You're probably going to flip it if you're lucky. And that's not what you want. So here you take some control authority away from you in order to give you some stability. Then at the bottom here we have angle of attack damp. So what that does is it adds pitch to decrease the angle of attack. So that again gives the fly-by-wire system authority over your pitch. And then G-damp, which does the same thing to try to decrease your G-force. So say you are pulling a particularly hard turn, the fly-by-wire system will limit you from going too hard into that turn at a certain G amount, or try to reduce the G-forces. And then slip you can think of as the plane is kind of slipping back and forth as it's trying to go straight. And if you adjust this, the fly-by-wire system uses the yaw to try to stabilize that. These bottom two boxes here, AOA limit and G limit, that gives you a limit of the range of either of those values. So angle of attack is relative to the direction the plane is going. So if it's going dead straight, how far up can it angle or down can it angle? And this isn't relative to like the horizon or absolute zero. Say the plane is flying straight up, well, not straight up, 45-degree angle up, right? If it tilts upward 15 degrees from that 45, that's only a 15-degree angle of attack, not a 60. So anyway, hopefully that makes sense. You can do the same thing with your G's, so if you don't want the pilot to die, but we don't care about that here. And then there's auto leveling, which again, self-explanatory. You can do speed limits, you can get warnings, whole bunch of stuff you can do here. And then there's actually more down here. Let's see, am I all the way down? Yeah, okay. Warnings, you can actually change the cockpit stuff. You can change the seat and the helm. Ooh, vintage. Nice. Even better. Oh, lovely. Okay, so let's do a baseline test here. I am going to remove all these fly-by-wire values, and we're going to fly this thing. And you guys will see why it's such a bad idea to fly something like this without a fly-by-wire system. Alrighty, here we are on the runway. Let's try to take off. You guys are going to see quickly how well this goes for me. This plane is huge, by the way. Alright, let's add some lift, and you can see it It does not like to fly. That wasn't even a good demonstration. Let's try that again. Basically what happens, and there's some science behind this that I won't bother explaining because I don't think you guys will watch it, but basically the control input, you create a positive feedback loop and everything goes wrong very quickly. So let's just, rather than go crazy, let's just trim the pitch upward. There we go. And I guess we can stow the landing gear. Okay. She's unresponsive, so more throttle it is. Okay, you get the point. It's completely unusable without a fly-by-wire system. Now, let's go back to the hangar, and let's plug in our values one by one. Let me pull them up here, and you guys can see firsthand the difference that this makes. So, let's go back to the cockpit. All right, we want a little more pitch authority or pitch gain because, you know, we want this thing to actually use its pitch control surfaces. So I'm going to move that up to 1.2. The roll gain and yaw gain are fine as they are for our damp pitch rate. So this is how much the fly-by-wire is going to try to keep us steady on the pitch axis. If you were paying attention to our flight, you'll notice we pitch down or up or whatever very quickly and at very low speeds. So we're going to need to give the AI quite a bit of authority on that. So I actually set this at 0.9. And then for the roll rate, 0.5, and the yaw rate, also 0.5. Again, these are not as unstable, the yaw and roll, as the pitch is. You could probably get away with smaller values on this. In fact, let's take this one down to 0.3. But I wouldn't risk it. As for the pressure damp, again, pitch is the problem here because we tend to pitch out of control. So I'm going to put 0.25. Oh, we've gone orthographic here. 0.25 as our pressure damp pitch. However, for roll and yaw, we're going to just leave it. We don't really need to do anything with those. So anyway, let's fly this thing and see how much that changed. And I will also point out an interesting thing that happens when you go supersonic with one of these systems. All right, so let's begin our takeoff here. Throttle up to 20%. These engines are way oversized, so we don't need to go too crazy. Apply a little lift, and there we go. Smooth, hands-free. Okay, maybe I shouldn't be so quick to say that, but as you can see, it flies, and it flies straight. It's not doing anything weird. It's not misbehaving in any way. I can control it just fine. You'll notice it has a bit of slip. There are things we can do to fix that, but at some point with fly-by-wire craft, you have to be mindful of, are you fixing a hardware issue with software? So like, would it be easier? I could fix the slip in the fly-by-wire system, or I could fix it by adding bigger vertical stabilizers. You got to think about what's a real solution to my problem. Now for our pitch input, you can see it's pretty moderate, and that's because the fly-by-wire is preventing us from over-inputting this. And I've actually just messed it up. Apply a little throttle and that'll be just fine. So let's just do a turn for kicks here. Again, oh, this thing actually slips pretty bad, even with the fly-by-wire. So we're turning. Yes, very nice. And there's a little flip. So as you can see, even with this, it's not perfectly optimized. The fly-by-wire system, there's still some significant issues. As you can see, it's trying hard to stabilize itself, but it seems to be having some problems. There we go. Okay. So again, it's good, but it's not fully optimized. You can tweak these values and you kind of have to experiment with every craft to understand what's really the best. But as soon as we go supersonic here, I'm going to take my hands off the controls. You'll see what happens very quickly. So we start to go up, and then if I steer down into it, we start to pitch down, pitch up, we get this sort of oscillation going that actually prevents the plane from going supersonic and staying stable. The exact science behind this is a little bit complicated. It has to do with the fact that the center of pressure changes its location when you go supersonic. So you have to really tune the fly-by-wire system well to get a supersonic craft to function properly. But yeah, that's what it looks like when it's been tuned almost properly. This thing still probably could use a little more tuning. Let's look at another craft to get another example on here. So this plane is a bit more unconventional. We have kind of an inverted wing thing going on here. Believe it or not, planes like this have actually been produced and flown before with pretty good success. There's no real reason why this design shouldn't work. It just looks really strange. And if we look at the center of pressure location on this relative to the center of lift or center of gravity here, it's behind it. So this is the opposite of the plane that we just flew. So this should be conventionally stable. However, if we click on the cockpit, actually I don't have a fly-by-wire system on this, but you could benefit from using it on this craft. I didn't in this case, but you definitely could apply it. For some unconventional design tips, one thing you can do, wings work in any configuration as long as the center of lift, again, remains behind the center of gravity if you want it to be conventionally stable. You also want to have large control surfaces, such as these, and generally you want to have one control surface devoted to only one input. So these only do roll. These only do pitch. I always get them confused. And these only do yaw. But let's fly this thing just for kicks and see how it does. Again, this is not a good fly-by-wire example because it doesn't have one, but it's a good example of an unconventional plane flying pretty well, I think. So let's try this thing out. Go, little buddy. Oh, it's pressing down into the ground. That's never good. Away! There she goes. Nice little craft. Very cool. Flies great. Actually controls remarkably well, which I wouldn't expect from something so strange looking. But that's another tip for you just generally, is never let appearances deceive, especially with stuff like this. Oftentimes, even if it doesn't look like it could fly, if it doesn't look like a good aircraft, you might be surprised. This thing's pretty quick. Oh boy, and it hits those. Oh, this is so bad for the poor pilot. What's his name? Jimmy? I forget. I always forget. But yeah, another tip. This is just generally good practice. So your engines, right, they provide your thrust. So we could get another little ball icon at the center of these engines, like right here. That is our center of thrust. We want our center of thrust generally to be in line with our center of gravity. The reason for that is because if the thrust is not in line with the center of gravity, it creates a moment, which is an engineering word for a twisting force, which causes the plane, in this case, to want to go like this all the time. However, it's not a big deal in this plane. Anyways, this thing's pretty cool. No fly-by-wire, but it's fun to fly. Let's see how well Jimmy survives a little crash. Actually, we'll do an epic fly. There we go. And switch to flyby. Listen for the sonic boom. Oh, I gotta pull up. Come on, buddy, go. Never gets old. Alright everyone, so that has been our tutorial on fly-by-wire systems and slightly more advanced planes. At this point, if you're following along in this series, you should be a little more confident in trying out ideas that maybe seemed a little crazy at first. Rule of thumb, I would say, is that almost anything can be made to fly with fly-by-wire in this game. If it generates lift, it has control surfaces, and you put some form of thrust on it, you can probably make it work if you experiment enough with fly-by-wire stuff. There will be a third installment in this series for what I'll call special cases and especially strange aerospace phenomena. But this stage of learning this game should take you plenty of time. So if you have any questions, feel free to put them in the comments below. Myself or someone else in the comments who knows better than I do will help you. But this game is really fun and really rewarding to play. I would highly encourage you to spend a few hours to learn it. You'll find yourself building much cooler planes as a result. But anyway, thank you so much for watching this video, and I hope you have a wonderful day.